Welcome. I'm so glad you're here with us today. I'm Whitney Lee. I'm a developer advocate. And I'm here with Henry Avetisyan. Henry, will you introduce yourself, please?
Hello, everyone. My name is Henry Avetisyan. I am a software engineer at Yahoo. And at the same time, I'm one of the lead maintainers for AuthN's, which is a CNCF sandbox project responsible for supporting service identity authentication and authorization.
And we're totally going to dig in on that. Henry and I just had a 2-hour-long conversation about Athens, and we're going to impart that knowledge to you here in about 20 minutes or so. But if you do want to see our 2-hour-long conversation, that'd be great. We're going to link to that in the description. But meanwhile, let's do a summary. So, Henry, will you tell me, what was the world like before Athens that caused it to get created?
Sure. So typically you had your own private data center where you had some type of a network access layer protecting your instances from the outside world. Everything was, pretty much IP based, most likely using HTTP. Everything was, plain text, nothing to worry about. There was no encryption. All services being able to connect others.
The total Wild West.
The total Wild West until something happens, quote unquote, something happens. And then you go, we should think about, making things more secure. And at the same time, there was lots of conversations starting about zero trust security. And if you look at some of the core principles of zero trust security, you always think about how do we do encryption? How do we make sure everybody is authenticated? And authentication itself is not enough. Everything wants to be authorized. So that's where basically we started at Yahoo about humans we understand. So we have services out there in the world that already provide identities for humans, whether it's authentication, two-factor authentication. But there was no concept of how about services? We have services being everywhere and anywhere. And what things made a little bit more complicated was all the public clouds. Before you had your own data center, okay, I'm running within my data center, everything is good. But now, some teams are saying, well, great, this is great, but I want to utilize public cloud. AWS.
And not just one public cloud either.
Not just one, exactly. Multiple. They would do their due diligence and go, I want to use this functionality and AWS does great at this one. So I'm going to use AWS. And then some other team would come in and go, oh, yes, but I want to use this and I'm going to use GCP because they're good at this. So in a sense, now you have these workloads or services, we call them, now being deployed everywhere. So you no longer have this nice and secure, I have this 10, 15 IP addresses that I need to protect. Now they're like all over the place. So now you want to make sure everything is secure across the internet, so to speak. And now you want to make sure everything is encrypted and authenticated and authorized.
I'm going to go out on a limb here and say that I bet Athens is a tool that's going to help to do this. Can we explicitly say how Athens relates to this problem? I think you did a great job of presenting the landscape. What does Athens do to help with this?
So we provide a set of services, and it provides basically two major functionality. One is we want to be able to issue an identity to all the workloads that are supported. And the workloads could be running anywhere and everywhere, whatever is supported. And we want to be able to use some type of an industry standard way to identify those services. And our solution is based on XOVNN certificates. So in a sense, every single workload running somewhere will get an identity in a form of an XOVNN certificate. And what that allows us to do is it can now establish mTLS connection with all other services that are also supported by Athens. So in a sense, you now have client and a server. They both authenticate each other. So the client knows it's talking to a specific server. Server knows that a specific service is talking to its resources. So now we have a mutual TLS, and that's the only authentication part. And then the second part that Athens provides, it also provides a role-based authorization system that just because you're authenticated doesn't mean you should be able to do everything, right? You need to be authorized. And again, here, we decided that we're going to use another industry-based, standard-based solution, OAuth2's access tokens, to pass that authentication, that authorization information as part of the request. So now you can be both authenticated and authorized.
I love it. To rephrase what you said, Athens is a set of services that provides authentication by issuing identities to all the registered services. And then it also provides a role-based authorization. And it does that using access tokens that we'll talk about later. And so we talked a little bit about how it's structured. It's designed to have one instance of Athens that's running company-wide. And then there's some constructs within Athens that help to isolate different sections of your company from each other. We talk about that a little bit?
Sure. So the idea was like, when we started designing this, we wanted to be a multi-tenant from day one. Nothing stops you from saying, I'm going to run 10 different Athens instances, all completely, one for this product, for that product. But there's absolutely, that generates lots of operational aspect, right? There's no need to have 10 different teams running Athens. The idea that we wanted to do was we wanted to run multi-tenant, delegated administration, completely isolated from each other from day one. And that's the idea is we introduce this concept of a domain. So you can think about say like a namespace. A domain itself is not sometimes good enough. So we always have this concept of subdomains because you have a product, you have sub-products, and then you also have different environments. So the example we have here, for example, you have a product called sports, but sports could have kind of like a sub-product like sports, NHL, NBA, NFL, MLB. And then within each one of them, you can have different environments because your identities should not be the same. Your identity for running your production workloads is not the same as your workloads running your development or staging. So you can have a subdomain structure called sports.nhl.prod, sports.nhl.stage, sports.nhl.dev. And then within one of those domains, now you can actually define your services. You can have an API service in all those three domains, and they're completely isolated. Now you have a complete delegated administration. So for example, your prod domain, only your SREs or your production engineers who are managing that in production should have access to it. Or your dev environment, only your developers, because they're gonna run tests, they're gonna do a whole bunch of proof of concept, do a whole bunch of different things. They can be the admins, fully delegated, completely isolated. So now you have a nice delegation and nice administration without, having one stepping over each other or somehow have an issue of security is concerned.
So we're talking about workload identity. There's so many workloads, so many services running in a multi-cloud like environments on-prem. How do you begin to establish identity for every single one of these workloads in a uniform way?
If you think about Athens does not know about every single workloads, right? It can't just claim that I know every single workload that's running within GCP. It has absolutely no knowledge, or AWS. What we have is a concept of providers, which we'll talk about later. When we were thinking about how to give you an identity and extraordinary certificates, the number one requirement for that is, you have to have a private key. But if I say that I'm going to generate a private key somewhere else, and then I'm going to transfer it to you, to the workload, now we have a problem. Well, you have a workload that comes up, has no identity, yet somehow it needs to securely get the private key. The only way to solve this, when the workload comes up, it needs to generate its own private key. It will be a unique private key for that workload. And the requirement is you need to make sure that that private key never leaves the workload. That gives you great security. So now you have an agent running alongside that workload. And it could be an API based, or it could be something like, for example, in Kubernetes, you can have a sidecar, a container that runs and does a whole bunch of work. So in a sense, we have an agent. What the agent does is first generates a private key. It's now unique for that workload. The second thing it does, it needs to collect some type of an attestation data to identify the workload. Because when you go to ZTS and you say, I want an identity, ZTS has to have a way to authenticate that request to say, yes, you are that service, I'm going to give you an identity. Next one, it generates a certificate sending request, CSR. Now it has private key, generated CSR, collected the attestation data, and then it's going to collect all this data and submit to ZTS and say, here's me, I want to request an identity for my service. For example, in the example above, we called it API. In my domain called sports.nhl.prod, I want an identity for that service, and here's my attestation data. Can you please give me a certificate?
When you say you submit to ZTS, you mean submit to the Athens server?
Correct. ZTS is one of the components in the Athens server, so I will use that interchangeably. So Athens, if you think about it, it has three major components: ZMS, which is the management system; ZTS, which is the token service; and then there's the UI component, which provides the UI interface for all of the management aspects.
So the agents gathered all this stuff and submitted it to the Athens server, and then what happens?
Athens receives this request that says, I'd like to get a certificate for this service identity. In this case, for example, we started with the Kubernetes, so the provider is the Kubernetes. So ZTS itself doesn't know anything about this workload, right? However, it has the concept of providers that whoever is using Athens has implemented. We implemented providers for AWS, GCP, Lambda, ECS running on Fargate, EC2, EKS, Kubernetes clusters, GKE, very similar, support running on VMs, running in GKE or Google Run functions. We have very similar with Azure or using Kubernetes directly. So there's these providers that have the knowledge about the workload. They need to implement the interface that Athens requires. So what Athens does and goes, here's the attestation data, and here's the provider that is responsible for that workload. I'm going to do a quick authorization check to make sure that the service is required to use that provider. And once that authorization check passes, it actually contacts the provider. I just received the request. Here's the attestation data. Can you verify if this attestation data is valid? And that all that logic, as far as how to validate a workload, actually belongs in the provider, because the provider is the one that knows exactly who's deploying that workload and how can be validated. And that's the core job of the provider, is to verify all the data and at the end to say, yes, this is a valid request. ZTS goes ahead, takes the CSR that was submitted as part of the request, goes back to its certificate signer, because in this state is acting like a CA. Takes the CSR, signs the certificate, it now sends back a certificate to the workload. So now workload has a private key, has a examination certificate, and now it can actually establish mTLS calls with any other service that requires mTLS within the infrastructure.
So one thing we talked about as part of that is the CA part of Athens, the fact that Athens could be a certificate authority. And so the certificate authority's private key is like the key to the kingdom. So it needs to be kept safe.
Yes, absolutely. That's one thing, like, when I tell everybody who's thinking about Athens is like, remember, you are acting as a CA. As a CA, your private key has to be the most secure thing ever. We provide some examples how to do that, but for a production use case, we definitely recommend to use HSMs, hardware security modules, to store your private key. If you don't want to buy a hardware device for HSM, you can also utilize HSM services provided by public cloud providers. So you can use those to store your private key, because those are the ones where you can say, I stored a private key, I can never extract it, it's there, so therefore it's secure. I can use it to sign, but it can never be compromised and stolen, because once somebody steals your CA key, they can issue any certificate they want, and that's something you want never, ever, ever to happen.
And so speaking of being compromised, we talked about what if an Athens certificate is compromised, or how would you revoke a certificate if something gets compromised?
So that's, every time you talk about certificates, the first questions I get asked is like, how about revocation lists? Revocation lists are quite expensive, complicated, outbound calls need to be made. So when we started looking at this was the question everybody asked, right? So we're talking about, multi-million requests a second happening in real time. So one thing we were told, like, don't do CRLs, don't do revocation lists. Instead, what we should be focusing on is short-lived certificates. So don't give out certificates valid for 12 months or 6 months or 3 months, because if the certificate is compromised and you don't have a CRL, now that certificate is valid for 3 months. Our solution should actually issue certificates for a much shorter period. Because if you have a certificate valid for 6 hours, obviously you need to refresh them, right? So we typically, what we recommend is whatever timeout you choose, halfway through, you start refreshing them. So you have a certificate valid for 6 hours, 3 hours in, you should start refreshing it, because the goal is your identity can never be without a valid certificate. Because once you have an identity without a certificate, you have an outage.
The big plot twist is that there is no revocation. Instead of revocation, if something gets compromised, you just don't refresh the certificate once it expires.
And the next thing we do here is, because every workload has a unique certificate, by looking at the certificate, you know exactly which workload that was issued to. So you can actually go back and look at that workload and go, how was that compromised? So now we can just narrow down to one specific instance of that. Quite helpful with debugging. One thing we also do in Athens is we monitor the certificates that were issued. So the first one is obviously you're getting your identity. So that's just a regular TLS request. It can't be mTLS because you have no identity yet. But once you have your identity, the next request for refresh, it's actually now you have an identity. So now we require you to do mTLS. And one thing we do is also, every certificate request, if you're familiar with the structure, it has a unique serial number. And what Athens does, it keeps track of every single serial number that was issued for the service. And we monitor to make sure that everything happens in sequence. So you have serial number 1, 2, 3 comes in and refreshes 4. And then somehow we get a refresh request for the same identity, for the same service, same instance ID, but it comes in with the service identity with serial number 2. Well, hold on. We already issued number 4 to you. Why are you coming in with number 2 here? And what we do is, in that case, we revoke the certificate. We notify the domain admin and go, hey, something happened here, something bad happened. So you need to go figure out what happened, and then rebootstrap a new workload with a new identity, because the old one, we've already revoked it. It can no longer refresh it. Because again, it's another aspect that we can do to figure out if there's something is fishy going on and possibly revoke it right away.
And I like the word refresh. The word refresh really drives home this certificate expired. We're getting a brand new certificate. There's a new serial number on the certificate. I like that. Revisiting what Athenz is, Athenz provides secure authentication, and we've really gone into how that works, which I love. But Athenz also provides role-based authorization. We have a workload. The workload has identity. But now, how do we establish what that workload's allowed to do and what other workloads it's allowed to talk to?
And this is where we're using a role-based authorization system and using yet another industry-based structures like, OAuth 2 access tokens to give you additional authorization capabilities, where I can give you an access token that says what are you authorized to do. And the authorization simply comes down to 3 components. If you are allowed to assume a specific role, then you are authorized to execute the action on a specific resource. So role itself is an Athenz construct. It's a role I define within my domain. As a domain administrator, I define what services are authorized to assume that role. But the action and the resource, you reference them in your policy, but Athenz doesn't know anything about them. So as a database vendor, for example, you might define my actions are insert, delete, select, update, whatever those actions are supported by your service. And the resources could be tables, or you can say, you know what? I want to be able to do authorization much more fine-grained level. I'm going to do at the row level or column level. Completely up to you. Athenz does not understand them, nor it cares about them, because at the end of it is what you're going to get from Athenz is an access token. It includes the role information, but the actual authorization check is going to happen within your service. So you will actually know about the action and resource, and based on the action, based on the resource role defining the access token, you can actually complete your authorization check.
And you talked a little bit about replay attacks too, and how those can be prevented. Will you say what a replay attack is?
Sure. So one concept there with the access token is you could see like, hey, we're debugging something and then we're looking at the headers, because access token usually comes in as a header in the request, right? It's typically like, the way you follow the standard is it's an authorization header. It's a better access token. It's all in, sometimes by mistake, they're exposing their access tokens. They didn't pay attention now, like their access token that's valid for next 3 hours, 4 hours, 6 hours. It's now in somewhere in public domain that anybody can use and replay. So I have the access token that somehow somebody accidentally exposed it. I can take it and just replay it attack. I can just replay it as long as it's valid. I can do all the operations that are authorized by that role. So we thought about that, like, how do we prevent that? There's an industry standard-based RFC that defines how to prevent replay attacks by defining mTLS-bound access tokens. And what this does, it actually binds the certificate. So when you go to Athenz, you request an access token. So you use your certificate to authenticate yourself to Athenz, and then you get an access token. And what Athenz does, it says, okay, you're requesting this specific role access token. Yes, you are authenticated, and you are authorized to assume that role. However, what else I'm going to do is I'm going to take your certificate, take the fingerprint of it, and I'm going to include it as one of the claims in the access token. So now you have an access token that says you have access to this role that allows you to write to the database. But one of the claims is also the fingerprint of your certificate. So when the client takes this information and sends it to the server, so server looks at the access token using the obviously standard-based implementation. It needs to know the public key to validate it, looks at the issuer, goes talks to Athenz, all standards-based stuff here, nothing proprietary, extracts the public keys, verifies the signature, and says, yes, this token is valid. However, it also says, there's also a confirmation object claim here. It says what the certificate should be. It goes and looks at the certificate that the request was made with, takes the fingerprint and goes, does this match? And if it doesn't match, now we have a replay attack. It means somebody is now using the same access token to submit the request, and it rejects it and goes, this is compromised. I'm going to reject this request. And now that means like, hey, if one of the developers by accident exposed the access token in one of the, like, for example, in your Slack channel, and somebody else is now trying to reuse that access token, it's going to be rejected because the certificate is no longer matched. And it's like, from the security aspect, this is actually great. Now you can no longer replay access tokens. Quite useful RFC. And we're quite happy that we're actually implementing that, and teams can actually take advantage of it.
And that leads us to one more subject to talk about, and that is the future of Athenz.
So we have a couple of nice integrations that we're working on. One is the Cert Manager. That's another CNCF project. If you have a Kubernetes cluster with 100 or 1,000 workloads running, you have hundreds and thousands of these agents running. Obviously, they're like, the container itself is actually does not require a lot of resources. So you allocate very small amount, but thousands of small amounts usually adds up, right? And the question is like, can I get rid of it? And Cert Manager is actually a great example. So what we've done is we've integrated Athenz as one of the plugins for the Cert Manager, and can actually implement all the steps that we talked about for the agent. Generate a private key, collect attestation data, and then generate a CSR and submit to Athenz. So in a sense, you can have one of these Cert Managers running in your cluster that handles the traffic for all your workloads running within that cluster securely, and it gives you an identity to each one separately. And now, instead of having 1,000 mini, eliminate
for the sidecars,
running all the sidecars. Exactly. And it's like, from the cost benefit, it's a great one. The other one we talked about, like, obviously, what if you are using GitHub Actions to deploy your projects? One option we have is, hey, we can actually integrate GitHub Actions as another provider for Athenz.
Cool.
So in a sense, if you're running a GitHub action, it can get an identity. And if it needs to make an mTLS call to some other service, maybe like as part of your GitHub actions, one of the steps is to do some unit tests. And unit tests, you have to talk to your staging server to get some data to validate some stuff, right? And for that, you need the mTLS, you need an identity to do that mTLS connection. Having a provider for GitHub Actions gives you that capability. Your job can now have an identity, it can make an mTLS call, and it's, now you can actually do your functional tests within your GitHub Actions itself. That's another one. We're also going to standardize on OpenTelemetry for observability. And then the last one, the big one, is like microsegmentation. We want to do identity-based microsegmentation. And obviously, we'll have more details about this one once we publish it. But this is one area we're definitely looking at to see how we can actually utilize identity-based microsegmentation to secure, communication more and segment the access a little bit more, make it more secure for our products.
This has been absolutely amazing. Thank you so much for sharing your time and your expertise with us. I've loved learning more about Athenz. I do have one final question. If I want to learn more about Athenz, where should I go next?
For documentation, I would say start off with our Athenz.io webpage. It has links to all of our documentation. We talk about all the functionality we support in much more detail. We also provide links to our email groups, plus our Slack that you can actually connect, talk to us directly. All the maintainers and implementers are in the Slack channel. So if you have any questions and you're trying out things and you want to have any specific questions, or you want to talk about how to extend your provider or write your own provider, we'll be happy to answer any questions you have about Athenz.
Thank you so much. Goodbye.
Thanks, Whitney. Bye-bye.
Ready.